BusinessNet Explorer, product news podcast channel. This is B&E Product News, supporting specifiers and buyers. This podcast is sponsored by the B&E Product News podcast library. Hi, this is Mick DeLayburn for BusinessNet Explorer. In this edition of the B&E Brand Leader Interview podcast, we discuss how to select and size a dehumidifier for a commercial situation. Dave Marshall-George, UK Sales Director at Humidity Control Specialist Condair, joins us on the phone to help us to understand a bit more about dehumidifiers. Hi, Dave.
Hi, Mick.
Dave, pleasure to have you on the podcast again today.
It's a pleasure to be here again.
Brilliant, thank you. So, Dave, what type of dehumidifier projects are we looking at today?
Well, dehumidifiers are used in many industrial processes. They basically remove moisture from the air to lower the ambient humidity and maintain a specific environmental condition. In manufacturing, they create an environment that's ideal for specific processes or material. It's used in places like museums and galleries, and they protect artifacts from the damaging effects of high humidity, like mould. And in places like swimming pools, they protect the building fabric itself, and also the people inside. And very high humidity can be uncomfortable.
Okay, so from your experience, could you talk us through the key things any consultant or contractor ought to be considering when setting out on this type of job?
Yeah, sure. Drying projects can be very tricky if you don't have much experience with the products. You see, it's not just about the physical act of removing moisture from the air, but also about managing the temperature. And this is because of both the thermodynamic principles involved and the technologies. So setting out, the first question to ask a client with a drying project is, what is the temperature of the area involved? And this is frequently the largest deciding factor in what type of dehumidifier to use. You see, there's two main types, condensing and desiccant. Now, condensing dehumidifiers work very efficiently in ambient room temperatures of around 20 degrees C, and they rely on moisture condensing on a cold surface inside the unit. So the colder the air, the less condensation happens. When temperatures drop to around 15 degrees C or less, condensing dehumidifiers just aren't very effective. So desiccant dehumidifiers become the preferred option. Now, they need more energy to operate and can be more complicated to install, but as they remove water from the air by simply absorbing it like a sponge, they work well in either warm or cold areas.
Okay, so the condensing type is good for warm areas and desiccant for cold.
Yeah, but it's not quite so simple. Both types of dehumidifier will actually add heat to the air during the drying process. So the next question to ask is, how sensitive is the area to heat gain? Now, when water changes its state from a gas, as it is in the air, to a liquid, which is what the dehumidifier is doing, the thermodynamic process results in around 0.63 kilowatts of heat being generated for every kilo of moisture removed. Think of it as evaporative cooling in reverse. And in fact, desiccant dehumidification results in even more heat gain. This is because in a desiccant dehum, a heater is used to blow hot air through a section of the desiccant rotor. Now, this removes the absorbed water from the desiccant rotor and blows it outside via ducting. Now, the residual heat from this rotor regeneration process will add even more heat to the process airflow than is already happening from the thermodynamic process. So both types of dehum will add heat when drying, but the desiccant unit can add significantly more.
Oh, so what if this becomes a problem, like it's uncomfortably hot for the occupants of the room?
If this heat gain causes an area to overheat, people in the room will often just open windows to let the heat out. But this causes problems as that lets more moisture in, which negatively affects the humidity control. And we can combat this heat gain in a condensing project by using an external condenser unit, very similar to split air conditioning units, when the external condenser part sits outside. And in the desiccant systems, cooling modules can be attached after drying to bring the supply air temperature back down. But the point is, it's an important part of the planning process, managing not just the humidity, but the resulting heat. A quality manufacturer should always be able to give you very precise details on the level of heat gain a system will deliver and how best to counter it. So always best to ask.
So apart from the ambient temperature and heat gain, what should be considered next?
Well, the next question is to ask what humidity level is needed in the area and how much variation is acceptable. Environments such as clothes drying rooms or swimming pools don't need extremely dry conditions. Simply maintaining a mid-range humidity of around 50 to 60% RH is enough to stop condensation or mould forming in these areas and meet the client's needs. Now, these projects largely go to the condensing route as they're ideal for this type of control. However, environments such as battery production or some pharmaceutical manufacturing processes will really need very low and very accurate humidity control. Now, for these projects, only desiccant humidifiers will do.
And what is the reason for that? What is it about desiccant systems that give closer and lower humidity control?
Well, desiccant dehumidifiers can be placed in series, one after another, with cooling or heating modules to meet an exact temperature and humidity condition. This means that they can deliver humidity control potentially as low as 1% RH and sometimes even lower. This is unachievable with a condensing technology as it's limited by the cooling core's ability to condense moisture in a liquid state without freezing it.
Well, desiccant systems are sounding like the more flexible solution, Dave.
Yeah, they are on performance, but they do use more energy, which leads us nicely to our next question, which is what energy is available for drying and how much. And with the high cost of energy at the moment, the question is really important, particularly for a high capacity project. A condensing dehumidifier is typically the more efficient option of the two, as it consumes about 0.5 to 1.5 kilowatts of energy for every kilo of moisture removed, whereas a desiccant dehum will use 1 to 3 kilowatts of electricity per kilo removed.
Well, that's quite a big difference, twice as much. So why such a difference?
Well, the energy needed to operate a desiccant unit is used mainly to heat the regeneration airflow, and the temperature of that airflow needs to be somewhere between 90 to maybe as high as 120 degrees C.
That is hot. How is that heat produced?
Well, normally with an electric heater, but if there is waste heat available from another process on site, this can be used with a heat exchanger to preheat the regen airstream and reduce the energy burden. And to further reduce the energy use, heat recovery can also be put on the outgoing regeneration air. This scavenges some of the heat from the exhaust air prior to release outside. And using both strategies could significantly reduce the energy needed to heat that regeneration air.
Okay. Are there any other drawbacks of using desiccants?
Well, the other main thing to mention is the simplicity of installation. Our condensing system is the easier of the two to put in. All it needs is a power supply and a drain. Whereas the desiccant unit will always need a duct to vent the wet regeneration airflow. Now, there's no liquid moisture within the desiccant system, so you don't need a drain. But the hot, wet exhaust air needs to be ducted outside. Now, depending on the location in the building, this can sometimes prove challenging.
Okay, so I think we've got a handle on the elements affecting unit selection. What's next on our list of things to consider?
Well, irrespective of what type of dehum is being used, now we need to ask questions to determine what size of unit is needed to meet the required humidity level. So basically how much moisture needs to be removed from the air. And to understand this, we need to look at how much moisture is entering the area's atmosphere. Well, firstly from outside, but then potentially from inside as well. Well, the outside moisture quantity is calculated using the known humidity and temperature of outdoor air, and the rate of air exchange within the area in question, the physical size of the area, and lastly what humidity and temperature is ultimately needs to be. And once all these details are determined, a psychometric calculation can be done. Now, this precisely determines the volume of moisture the dehumidifier will need to remove from the incoming outside air to meet the required indoor condition. Now, this calculation is something that a dehumidifier manufacturer will be able to provide guidance on.
And how about the water coming from inside?
Yeah, indeed. It's a good point. Any internal sources of water must then be factored in as well as the external sources. For instance, if the area is a swimming pool, then the internal load will be significant. The pool volume, the water temperature, and the hours of operation will help calculate the amount of evaporation. Now, people also give off water, and we do so at varying levels depending on our level of activity. Again, a quality dehumidifier manufacturer will be able to help with these calculations. But to do so, some specific details like the ones I've mentioned need to be determined.
Sounds like a lot to take into consideration.
Yeah, there is, but answers to all of these questions will create a solid foundation for a successful drying project. Also, be aware that not all suppliers offer both types of dehumidifier. And working with a manufacturer that offers both condensing and desiccant systems is really beneficial, as it avoids any selection bias, and you'll always get the right product based on your project's needs. And lastly, get advice from the manufacturer early on. We're always happy to explore options at any stage. Our advice is always free, and it can greatly improve the odds of everything going well.
Well, there you have it. How to select and size a dehumidifier. Rule number 1, talk to the experts. And thank you for sharing your industry expertise with us today, Dave.
Thank you, Mick. It's good to speak to you again.
And you, and look forward to the next time. You can find out more about humidification specialist Condair and the products and services they provide by visiting the company's website at www.condair.co.uk. And please take a moment when you can to check out the other B&E brand leader interview podcasts in this series that feature Condair and provide unmissable insights from Dave Marshall-George on subjects such as exploring the evaporative cooling opportunity for HVAC system specifiers, understanding the relationship between health and humidity is key to optimising indoor air quality, optimising humidity control to increase profits for food and drink manufacturers, and how dehumidifiers can improve safety and efficiency in cold stores and freezers. You can find these on the Condair website and the BusinessNet Explorer Brand Leader podcast playlist. Well, thank you for joining us for this latest edition of the B&E Product News podcast. And please, stay safe.
Follow us on Twitter at B&E Product News to keep updated on our latest product news podcast releases, and visit us at businessnetexplorer.com to find more product news and information for specifiers and buyers in the construction and building services and associated manufacturing and energy sectors.
BusinessNet Explorer podcasts are now available via the Apple Podcasts app, iTunes and on Spotify. You can subscribe to access our existing content and, of course, to receive every new podcast that we publish in audio format.